Hello everybody. So today we're going to talk about ions, cations, anions, and polyatomic ions. And what ions are they're groups of elements with a charge, or what we really call an oxidation number. And so today we're going to talk about what's the difference between all three of those and how you figure out what that charge is, that oxidation number that it might have. So let's take a look at this periodic table and just do a little review. These guys in the last group are referred to as the noble gases, and they are already stable, so they already have a zero charge associated with them. Now, if you look at the next family to the left of it, these are referred to as the halogens, or if we just want to call them the fluorine family. They are one away from the nearest noble gas. That means to become stable, they have to gain an electron. If they gain an electron, they'll become -1. And if you look at the family for oxygen, oxygen is 2 away from the nearest noble gas. So you probably figured out it's going to take on 2 electrons and it will be a -2. And you can see there's already a pattern that's forming here. Now something happens whenever you get to the carbon family. Carbon can be stable with either gaining 4 electrons or losing 4 electrons. It takes the same amount of energy really to kind of go either way. And the reason why that happens is because of the octet rule. The octet rule just says that the number that you're striving for is 8. Well, carbon's already got 4, so it has the ability to gain 4, or it has the ability to lose 4 to become stable. So if it ends up losing some electrons, it'll become +4. And then boron is +3. We're going to skip the transition elements because they're complicated. And then these guys are +2, and then we have a +1. Right? So those are the standard charges for most of the elements on the periodic table. Now, there are other charges that they can have. So, for example, oxygen. Oxygen almost always has a -2 charge. However, it could also give away some electrons to become stable. It could actually give away 6 of them. It's 6 valence electrons. Okay? Well, if it gives away its 6 valence electrons, it can also become stable. Notice that there's a pattern here. The 6 and the 2, when you add them together, gives you that total of 8. So what would it be for the elements within the halogen family where fluorine is? It could be stable with a -1, or it could actually get rid of 7 electrons and be +7. And then what would it be for the nitrogen family? Well, this is a -3. To add up to 8, this would have to be a +5. That doesn't typically happen, however. Usually what happens is the larger numbers here, the ones that are down here, they will typically, the nonmetals, do not want to lose their electrons. They usually want to gain them. The reason why I'm showing you this is so you can figure out what the charge is if you have an ion. So first of all, before we even do that, let's talk about what the 3 different types of ions are. So you've got a cation, you have an anion, and you have a polyatomic ion. And what's the difference between all of those? Well, a cation is an atom that has a positive charge. An anion is an atom that has a negative charge. And a polyatomic ion is a group of atoms together, and they're covalently bonded, and they can either have a positive or a negative charge. So let's take a look at those. So the cations are really easy to figure out because you guys all know about the staircase. Starts here, zigzags through the periodic table, and notice that the positive stuff is mostly over here to the left of the staircase, and the negative stuff is over to the right. So an example of a cation would be something over here within the metals region of the periodic table, and not the nonmetals. So let's pick maybe the element Mg. Well, Mg would have what charge when it's an ion? It would be a +2. So an example of a cation would be Mg with a +2 charge. What about for an anion? Anion just means it has a negative charge. It's going to be a nonmetal. It's something over here. Let's say we're going to pick the element sulfur. Sulfur typically will have a -2 charge. So an example would be S with a -2 charge. What about polyatomic ions? I'm running out of space up here, so I'm going to put those down here. But if we take a look at, for example, sulfate, SO4 has a -2 charge. Well, how the heck does it get that -2 charge? Well, let's just use the periodic table. So we got two elements that are bonded together. They're bonded covalently, and the sum of their charges has to add up to a -2. Not like a compound where it adds up to 0, but the reason why it's an ion and not a compound is because its net charge is a -2. Its total charge is that. Okay. Well, so let's take a look at oxygen. There are 4 of them. And then we're going to join it to sulfur. If we look at oxygen, oxygen typically has a -2 charge. There are situations where it can be a +6, but it typically has a -2. And what about the element sulfur? Sulfur, which is below oxygen, also typically has a -2, but there are some situations where it can be a +6. And when you have a polyatomic ion, one side has to be positive and the other side has to be negative. Okay? So in this situation, the front half is typically going to end up being positive, and the back half is typically going to end up being negative. Well, why does that happen? Well, for something to become negative, what does it have to do? Does it have to gain or lose electrons? It would have to gain, so because an electron is a negative thing. So whatever's going on here, oxygen is gaining electrons, and then the sulfur, the front half, has to be losing electrons. And how you can figure out whether something is going to lose or gain electrons is by using something called electronegativity. So here's a periodic table with electronegativity. Notice that electronegativity is something that is way over here on the periodic table. And as you move further away from that area over here, it becomes less electronegative. Well, what the heck is electronegativity? Because that's something I believe that hasn't been talked about yet. Well, electronegativity is kind of like an atom's ability to steal or take an electron. So let's use that as a definition. So electronegativity is the ability of an atom to take an electron or steal an electron, however you want to think of it. Okay, so if we take a look, if we had two elements and we had to compare them, let's say we're going to compare nitrogen and fluorine, look at where the most electronegative part of the periodic table is. It's way up here. Well, what's closer to that, nitrogen or fluorine? Fluorine is. So if you're going to basically join together nitrogen and fluorine, fluorine will take on the negative charge and nitrogen will take on the positive charge. Well, let's look at our example of sulfate, which is SO4. Well, if we look where oxygen is, it's right here. And if we look where sulfur is, it's below it. So which element is going to have the higher electronegativity? It's going to be the oxygen. Okay. Because oxygen has the higher electronegativity, it's going to take on more of a negative charge, and the sulfur, which has less electronegativity, is going to take on more of the positive charge. Right? So let's use that information to figure this out. So oxygen is -2 or +6. It's going to be the -2 because it wants to gain electrons more than sulfur does. So it's going to take on the negative charge. So we're going to label this oxygen -2. And for sulfur, even though it typically wants to have a -2 charge, when it's bonded with oxygen, because it's less electronegative, it's going to want to shed its electrons to oxygen, which really wants them. So as a result, it's going to take on that positive charge. It's going to take on that +6. And if you add all this stuff up, don't forget you have 4 of these oxygens, with each one having a -2 charge. So really your total negative charge here is really a -8. And what I like to do with my students is I basically have another layer here. I will figure out what these top numbers are, because these top numbers are the totals, and that's what I'll use to figure out what the charge is on those group of elements. Well, we only have one sulfur here. If there's no number here, it means there's one of them. 1 times 6 gives us a +6. So that's how you get that top numbers. You're really just multiplying. 4 times a -2 gives you -8. 1 times a 6 gives you 6. When you add those numbers at the top together, guess what you get? You get a -2. So that's how you figure out the charge on it. So let's try another compound. Let's maybe work with PO4. If we look at PO4, PO4 typically has a -3 charge. Let's see if we can figure out how to get that number. So take a look at the periodic table for electronegativity, phosphorus and oxygen, and compare where they're at. So if we take a look, phosphorus is right here, and then oxygen is right here. So again, which one is more electronegative? It's going to be whatever's closest to the X on the periodic table. It's going to be the oxygen. So it's going to take on the negative charge, just like it did in the other ion here. So it's going to take on a -2, because that's what we have. And that means that P is going to be forced to be a positive value. Well, P is right here. It's going to, instead of gaining 3 electrons, it's actually going to give up its 5 electrons to oxygen. It's really not giving them up. It's actually really just sharing, but it's sharing them unevenly. And you'll learn about that whenever we talk about covalent compounds later on in the future. But just know that the pattern is that one element is going to be negative, the other element is going to end up being positive because of that electronegativity difference. So let's figure out what the totals are, okay? 4 times 2 gives me a -8. And 1 times 5 gives me a +5. Sorry, I'm kind of looking a little sloppy here. I should have wrote it a bit lower. So if you add up those totals, if you add up the +5 to the -8, what charge do you get? You get your -3. So PO4 has a charge of -3. So I hope that helps you understand the difference between cations, anions, and polyatomic ions, and taught you a little bit about electronegativity and how is it used and figuring out that charge. And now you can figure out what the charge is on a polyatomic ion if you forget, and maybe you're taking a test or something, and you're like, God, I can't remember what that ion is. Well, now you have a method that you can use to figure out what that is. All right, see you for the next lesson. Bye.